Okay, we're going to be solving multi-step inequalities, so please go ahead and label your paper Solving Multi-Step Inequalities 7EE4. Just a quick reminder that when you see this first sign here, that means less than, and that when you go to graph it, it's going to be an open circle, and the arrow is going to be drawn to the left-hand side. The second inequality sign is the greater than sign, and so when you graph that one, it again is going to be open and the arrow is going to go to the right hand side. The next one is the less than or equal to. Remember, it doesn't have to be both, it just has to be one or the other. That one is going to be a closed dot, and it's going to go to the left. And the last one is greater than or equal to. Remember, it doesn't have to be both, just one of those, and it is a closed dot also, and your arrow is going to be drawn to the right. Okay, remember, you're going to solve these just like you solved two-step equations. So the very first thing you're going to do, we're going to circle the variable, bring down the wall. The only difference is we're always going to use the distributive property first. So I'm going to go ahead and rewrite this problem over here just to give me a little bit more room. So you have 4 times x minus 3 is greater than 8. And I'm going to, again, circle my variable, bring down my wall with my greater than sign. And then if you notice, it says always use distributive property first. So I'm going to use the distributive property, and I'm going to follow the rainbow. So 4 times x gives me 4x. Bring down my sign, minus 4 times 3 gives me 12. Now I can go ahead and get started again. I'm going to circle my variable. All right, this is telling me 4 times x minus 12, so I'm going to do PEMDAS upside down, parentheses, exponents, multiplication, division, adding and subtracting. Remember, I start at the bottom and work my way up. So I'm going to do the adding and subtracting first. This is telling me to subtract 12, so I'm going to add 12 on both sides, which cancels this out, leaves me with 4x is greater than 8 plus 12 gives me 20. Again, I'm going to circle my variable, bring down my wall, and then this tells me 4 times x, so I'm going to divide both sides by 4. That cancels out, which leaves me with x here, and 20 divided by 4 is 5. So when I go to graph it, my 5 is going to go in the middle, 4, 6 over here. It is going to be an open circle because I do not have the line underneath here. Remember, if I don't have the line, it's an open circle. My arrow is pointing, going to the right, so my arrow here will go to the right, and let's double check. If I plugged in any number to the right of 5, let's choose 6, if I plug in 6 here, and I rewrote it as 4 times 6 minus 3 is greater than 8, I can go ahead and combine like terms. 6 minus 3 is 3. 4 times 3 should be greater than 8, and 4 times 3 is 12. Is 12 greater than 8? Yes. So I know that I have a true statement. So my answer would be, or my solution would be, any number greater than 5. Again, this one is the exact same as the last one. You're using the distributive property first. So I'm going to go ahead and rewrite it again. 3 times d plus 2 is less than or equal to 12. I'm going to go ahead and circle my variable, bring down my wall, less than or equal to sign. All right, on this one, I'm going to use the distributive property first. So 3 times d is 3d. 3 times 2 is 6. All right, and again, you're following the rainbow. If you need to go back and rewatch the distributive property, please do. And then I'm going to circle my variable again. That means 3 times d plus 6. So I'm going to use PEMDAS upside down. All right, adding and subtracting first. So this right here tells me to add, so I'm going to subtract 6 on both sides, which cancels this out and leaves me with 3D. 12 minus 6 is going to give me 6, and then I'm going to circle my variable again, bring down my inequality sign. That says 3 times d, so I'm going to divide both sides by 3, which leaves me with d on this side. 6 divided by 3 is 2. Again, when I go to graph, I'm going to have my 2 and then a number on each side. Because I have a line under here, my circle is going to be colored in. And if you notice that my arrow here is pointing to the left, so I should be able to pick any number on this side of the arrow. I'm going to pick 1 and plug it back in. So 1 is going to be plugged in right here where the D is, so that leaves me 3 times 1 plus 2 should be less than or equal to 12. I can combine inside the parentheses, which gives me 3. 3 times 3 is 9. Is 9 less than or equal to 12? Yes, so that makes your solution true. Okay, this is the last example, but I want you to put a star beside this because this is very different. If you notice, you have a variable on both sides, and the problem with that is you need to have all of the variables on one side. So what we're going to do with that is we're going to go ahead and do the same way. We're going to circle the variable, bring down the wall, use the distributive property first. So you're going to start out the exact same way. So I'm going to go ahead and rewrite my problem. And I'm going to use the distributive property. 2 times g, negative 2 times g is negative 2g minus negative 2 times 1 is negative 2. I could go ahead and do the keep, change, and that was keep this, change this, change this. And then I can bring down my wall down here. All right, and then I want to go ahead and circle my variable. All right, this says negative 2 times g plus a positive 2. So since it's a positive 2, I know I'm going to subtract 2 on both sides. Subtract 2 on both sides here. That cancels this out and leaves me with negative 2g is greater than, and then I have a negative 4, so keep, change, a negative plus a negative. Remember, if you have same signs, add and keep, different signs, subtract. So I have same signs, so negative 4 plus negative 2 is going to give me a negative 6. So I have g minus 6. And then this is where it differs. All right, I have a g on both sides, so I need to get all my g's on one side. So since this side is a positive g, I'm going to subtract that g. Because that's like saying 1. I want to subtract 1g. So over here I'm going to subtract 1g again. That cancels that out. And I did forget to bring down my wall with my inequality sign. And then I have negative 2g minus 1g. So keep, change. So I have a negative plus a negative. Same signs, add and keep. So that gives me a negative 3g is greater than negative 6. And I'm not finished because remember, I still have a number with g and I need to get rid of all numbers. I want g all by itself. So with that, I'm going to circle my variable. Okay, here I notice that I'm going to have to, this means negative 3 times g. So remember back when we were doing just one-step equations, anytime you multiply or divide by a negative number, you have to flip the signs. Okay, so I'm going to take this greater than sign and make it a less than sign. All right, and remember, anytime you multiply / divide by a negative number, flip the inequality. Okay, so let's go ahead and finish this one up. So this says to divide by, this says multiply by -3, so I'm going to divide by -3 on both sides. That cancels, which leaves me with g. Negative divided by a negative. Remember, backtrack that. A negative divided by a negative is a positive. 6 divided by 3 is going to give me 2. So my solution is g is less than 2. That means any number that is less than 2 would be my answer. So when I go to graph it, I have my 2, my 1, my 3. It's going to be an open circle. Remember, it's open because there's no line under the less than sign, and my arrow is pointing in this direction, so I'm going to point it this way. When I go back to check it, okay, this is a key. When I'm checking my answer, I'm going to plug in whatever number I choose into both g's. So I can pick any number on this side. I'm going to pick the 1 because that's probably the easiest. So when I go back in, -2 times 1 minus 1 should be greater than 1 minus 4. Notice here I plugged in the 1 here and here. I plugged it in on both g's. Don't let that confuse you. All right. I can start here. 1 minus 1 is 0. 0 times -2 should give me 0. All right, I'm going to bring down my sign over here. 1 minus 4. Okay, remember I have a positive 1 and I'm subtracting 4. Think of money. If you have $1 and somebody takes $4 or you pay for something that was $4, you're now owing somebody, so you owe $3, so it'd be a -3. So is 0 greater than -3? Yes, so you know you have a correct solution. All right, the last one, if you will try these on your own, when you get stuck, if you'll just put a star by it or write yourself a question to remember to ask tomorrow during class. On the first one, remember that's just distributive property. It's the first 2 examples. The second one is just like the example I just did. Good luck.